full adders in Unit 3. So today we will be learning about half subtractors, full subtractors, decoders, multiplexers, demultiplexers, magnitude comparators and encoders. So Ma, when I listed all this, you may be afraid, oh my God, our ma'am is going to teach all this. Actually, they all belong to only one type. 1 minute. They are all combinational logic circuit. And what do we mean by a combinational logic circuit is, the output is dependent only on the present input. Whereas we have a sequential logic circuit in which the output is dependent not only on the present input, but also, but also on the previous inputs. So I am repeating. A combinational logic circuit is one in which the output is dependent only on the present input, whereas a sequential logic circuit is one in which the output is dependent not only on the present inputs, but also on the previous inputs. To give you a scenario, assume I were a student and in my practical examination class, I did not behave well with my practical teacher. So keeping that in mind, suppose if my teacher is reducing the marks in my semester examination, then she is an example for sequential logic circuit. Suppose on the semester examination, if I am getting verification of logic gates, and that's an easy experiment, and if I have completed it thoroughly, answered the viva properly, without remembering what I have done in my early classes, if my teacher is giving me 100 out of 100, then she is an example for combinational logic circuit. So in combinational logic circuit, people will not remember, people will not have memory, and hence there will not be any feedback. Suppose there is a feedback, and if they remember what I have done previously, then they become examples for sequential logic circuit. So I have given you a tabular column here. So the definition I have already said. For a combinational logic circuit, the output is dependent only on the present input. Whereas for a sequential logic circuit, the output is dependent not only on the present input, but also on the previous inputs. And I said feedback and memory only for sequential logic circuit. Therefore, I have given yes for sequential logic circuit. And feedback and memory not present in combinational logic circuit, so no and no. Then I have given you examples also. So in these examples, if you see, we have adders, subtractors, encoders, decoders, etc. On the other hand, for sequential logic circuit, we have flip-flops. So now in a combinational logic circuit, the circuit is so simple. We have n number of inputs and some number of outputs. That's it, no feedback. Whereas in a sequential logic circuit, it's basically a combinational logic circuit where part of the output is fed as input, which means the output is dependent not only on the present, but also on the previous. Having said this, now we are going to the next slide. Throughout the unit, we are going to follow only this grammar, and the grammar is this. In order to design any circuit, let it be combinational logic circuit in this unit. So in order to design any combinational logic circuit, first, we should understand the problem. The problem statement will be in English. So we have to understand it in terms of digital logic circuits. Then we have to determine the number of inputs and outputs. See, the second step is only determining the number of inputs and outputs. Then the third step is all about naming them. Then the fourth step is we have to draw a truth table. And then we have to form the minimized expressions for the output variables, and we have to realize a combinational logic circuit. So I repeat, whatever question they give, we have to understand it. We have to determine the number of inputs and outputs. We have to name them. Then we have to draw a truth table. So what is a truth table? It's just a relationship between the input and output based on our question. Then we should form the minimized expression for the output variables, and minimized expression. Finally, we have to realize a combinational logic circuit. That's it. So now let us take a question. We have to design a half subtractor. So if we have to design a half subtractor, First, what did I say? Understand the problem. So what is a half subtractor? So subtractor, we all know, it will give the difference, not only difference, but also the borrow. So it should give you a difference and borrow. And half basically in digital logic circuit means two inputs. Therefore, a half subtractor is a combinational logic circuit that has got two inputs and it will provide the difference and borrow as the output variables. The second step is we have to determine the number of inputs and outputs. Already in understanding the problem itself, we have found it clearly, two inputs, two outputs. So here we are writing, fine, there are two inputs and two outputs. The next step is to name them. So again, any English alphabet we can give, combination of alphabets we can give. For inputs, that doesn't matter. But when we are naming an output variable, that should have a meaning. An output variable either in digital logic circuit or in C or C++ always should have a meaning, which means in this particular example, if you see, we want difference and borrow as output variables. So the first letter of difference is D and the first letter of borrow is B. So we are going to consider D and B as our output variables. As we have considered B as our output variable, if I take A and B as the inputs, there will be a confusion because input also has B, output also has B. That is why I have taken X and Y. Again, if you insist, no ma'am, we will go only with A and B, it's fine. You can name A and B as inputs, but in the output, instead of B, you kindly put BO in order to indicate borrow. That's it. So now we have understood the problem, we have determined the inputs and outputs, and we have also named them. Next, truth table. So in this truth table, we have to bring out the relationship. So it is subtracted. We all know the grammar for subtractor. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. But 0 minus 1 is the challenge. So 0 minus 1 we cannot perform. So what we will do? We will borrow a 1. That is why I wrote here, we are having a borrow 1. And when you borrow a 1, 0 becomes 1, 0. 1, 0 in binary number system is equal to 2 in decimal number system. So it is 2 minus 1. 2 minus 1 is what? 1. That is why I have written 0 minus 1 is 1 with a borrow 1. See ma, I am repeating. 0 minus 1 cannot be performed as such. So what we have to do? We have to borrow a 1. So I clearly wrote for 0 minus 1, there should be a borrow 1. And when you have borrowed a 1, this 0 will become 1, 0. 1, 0 means what? 2. When it becomes 2, 2 minus 1 is what? 1. So that's why I have written the answer as 1 and borrow as 1. So whatever I have said here, we are going to write it in the form of a truth table. So here you see X and Y, because we already decided X and Y as the two inputs. Difference and borrow are the two outputs. So therefore, 0, 0. So I said 0 minus 0 is what we have to copy from here. 0 minus 0, difference is 0 and the borrow is 0. 1 minus 0, difference is 1, borrow is 0. 1 minus 1, difference is 0, borrow is also 0. On the other hand, if it is 0 minus 1, so here a borrow is 1 and the difference is 1. Now we have all written a truth table. What is the next step we studied there? We have to write minimized expressions for the output variables. So our first job is to find out who are all the output variables. So X and Y are input variables. So who are the output variables here? Difference and borrow. So we will take one at a time. Now I want to write an expression for D. We need not panic. First we should think in English. So the statement is this. We should find out when all D is 1. So D is 1 under two circumstances. When X is equal to 0 and Y is equal to 1, or X is equal to 1 and Y is equal to 0. First, I know we have to write an expression, but before that I want you to think in English first. Then only we can convert it into any expression. So if you see here, D is 1 when x is equal to 0 and y is equal to 1, or x is equal to 1 and y is equal to 0. Now kindly come to the clues part. Here what I have written, you see, if x is equal to 0, we have to write it as x dash. If x is equal to 1, we have to write it as x. Now, if you have an English word and, it should be replaced with dot. If you have an English word or, it should be replaced with what? Plus. So, keeping this in mind, so you see here, D is 1. 1 means you should write D as D. Is, I have put equal to sign. Then x is 0. When x is equal to 0, I asked you to put it as x dash. Then and is coming. So I wanted you to put dot. Then y equal to 1. Put y as such. Then r, O-R-R. R means plus. So plus x dot y dash. So I think you all understood. So first you should pick the output variables. One by one we have to do it. And the first output variable is D. So for this variable D, we should check where all we are having a 1. And we should think in English. We are having a 1 when x equal to 0 and y is equal to 1. R, O-R-R. X is equal to 1 and y is equal to 0. And then what we have to do? Whenever it is 0, you have to write it as dash. Whenever it is 1, you have to write it as 1. Few of your teachers would have taught you x bar. That is also right. Either x dash or x bar. In PPT, it was difficult to put bar above that. So that's why I did not put. Okay, ma? Fine. So now the final expression is D is equal to x dash dot y plus x dot y dash. Now let us come to borrow. Borrow is very easy. So in this borrow column, where we are having a 1, yes, what, only one place. So let us say in English, borrow is 1 when x is equal to 0 and y is equal to 1. That's what I wrote here. Borrow is 1 when x equal to 0 and y equal to 1. So b equal to, now 1. So when the value is 1, we have to write it as what? B as such. So I have written B as such. Is equal to, then x is equal to 0. So what did I ask you to write? X dash. Instead of and, I wanted you to put dot, and then y is 1. So we are having it as y. So finally, the expressions are D is equal to x dash dot y plus x dot y dash. And here it is x dash dot y. Now we have got the expression. What is our next step? We have to draw the circuit. But before I click to the next slide, I want you to understand the importance of the statement. D is equal to x dash dot y plus x dot y dash. So what is this? This is nothing but the very famous XOR gate. In your digital logic circuit, you would have all studied NAND gate is universal gate, NOR gate is universal gate, because we can realize any other gate with all those gates. But believe me, children, the most important gate in digital logic circuit is XOR gate, because if you remember, even for half adder you have used XOR gate, full adder you have used XOR gate for sum, for half subtractor it is XOR gate, for difference full subtractor again XOR gate, and if you have to perform gray to binary, binary to gray conversion, it is XOR gate. Then modulus 2 operation, divide by 2 remainder operation, if you want to perform, it is XOR gate. Likewise, the application of XOR gate is endless. Okay, fine. So now I think you have all understood D is nothing but X XORed with Y, and B, we cannot do anything, it is X dash dot Y. So I am going to the next slide. You see here, X and Y are the two inputs. So for difference, what did I say? We can put it as an XOR gate. So I have connected an XOR gate. And then here, it is X dash Y. So X is taken to a NOT gate. When you draw a NOT gate, even in hurry, you should not forget to draw this bubble, because if you don't draw a bubble, it will become a buffer. So what is a buffer? Whatever is the input, that will be the output. So that's wrong. So therefore, what you have to do? You have to draw a NOT gate with a bubble over here. Otherwise, it's not at all NOT gate. Fine. So X dash, then dot and operation. And here we are having Y. So I have given X dash and Y to borrow. So here is difference, here is borrow. So what is the moral of the story? They wanted us to design a half subtractor. A half subtractor will have only two outputs. One is difference and another one is borrow. So now we have realized it with the help of a single XOR gate and with the help of a NOT gate. And what is the other gate? It is AND gate. Okay, ma? Fine. So next, we are going to the next question. So if you see the next question, we have to design a full subtractor. So if you have to design a full subtractor, again, you need not panic. Understand the question. So already we know what is a subtractor. A subtractor will have two outputs, and those outputs are nothing but difference and borrow. But full in digital logic circuit, whenever you hear the word full, it means that three inputs. So we have three inputs and two outputs. So the next step you see, three inputs, two outputs. Then we have to name them. Again, our choice, either ABC or XYZ. Then as I said, we should name the outputs intelligently. So we named D for difference first letter, B for borrow. Then we have to follow the same grammar for subtract. Full subtractor also, full or half, it is basically a subtracted. So you have to follow the same logic. Fine. So I have given X, Y, Z, difference and borrow. Now we may be confused. Ma'am, there we had only two. Doing it was easy. You said we can copy whatever is here. But children, here also same logic. Let us take two at a time. First, we will perform 0 minus 0. So 0 minus 0 is what? 0. That 0 minus Z0 is what? 0. So therefore, difference is 0, borrow is 0. Then come here, 1 minus 0 is what? 1. Then that 1 minus this 0 is what? 1, 0. So likewise, it proceeds. So a little difficulty you will face when you are having 0 first and 1 next. There also no problem. Whenever you have 0 minus 1, blindly go and put borrow as 1, because I have already said that 0 minus 1 cannot be performed without borrow. So here you see 0 minus 1, borrow 1, 0 minus 1, borrow 1, 0 minus 1, borrow 1. Then here also you see 1 minus 1, it will become 0. So again it is 0 minus 1. So I have put a borrow as 1. Then this, again, you have to perform the subtraction and you have put like this. So here also the same step, we have to find the minimized expression for the output variables. Here also you have two output variables. What are they? One is difference and the other one is borrow. So you go to difference and say it in English. Difference is 1 when X equal to 0 and Y equal to 0 and Z equal to 1, or X equal to 0 and Y equal to 1 and Z is equal to 0, likewise. So that's what I have written. Whenever it is 0, let us check whether I wrote correctly. So difference is 1, first one. Where is it occurring, ma? X equal to 0, Y equal to 0, Z equal to 1. Okay, let us check. 0 means what I said? X dash. So I have put correctly. Then another 0 for Y. So Y dash correct, Z. So which means that I have written all these values correctly. Likewise, you have to write the expressions for B. Having written the expressions for D and B, in the previous case, we did not bother about a term called minimized expression, because that expression itself was minimized using a single gate, you have realized. But here, our expressions are having 4 terms, and in each term, you are having 3 variables. So we have to check whether we can minimize them or not. So for minimizing it, already in your first unit, you would have studied Boolean algebra, Carnot map, Queen-McCluskey tabulation. Boolean algebra, again, you need expertise. You should be an expert in that. Only then you can use Boolean algebra. And tabulation method, more than 4 variables. But here we are having only 3. So we are going for Carnot map. And this I have copied from our Maurice Mano book. So again, I'm not going to explain Carnot map for you. I understand you all know about Carnot map. So now just to give you an example, there I said you will be having a difference as 1, where 0, 0, 1. So in all those places you put 1. And here there is no possibility for connecting the adjacent squares. So you have an expression like this. On the other hand, come for borrow. So we have put 1 and then we understand we can group them. Fine, group it, minimize it. So if you see, we do not have a minimized expression for what? For difference, but we have a minimized expression for borrow. Again, Amma, this x dash y dash z plus x dash y z plus this is nothing but an XOR gate with 3 inputs. That you may not know now. Like on seeing this, our ma'am is saying XOR gate, but how will I know on seeing this expression whether it is XOR gate or not? That question, like it comes only with experience. But I can help you in understanding. You do one thing. You take a paper and then you check whether x XOR y bracket XOR with z is giving you this expression. It will give you many terms, xyz plus another xyz. You all know xyz plus xyz is xyz. So like that you have to minimize it. And finally you will understand it is nothing but an XOR gate. Okay, so it's okay to memorize. Let us not reinvent wheel. So it's okay to memorize and keep the difference expression is an XOR gate for a full subtractor. Sorry, here I wrote full adder. It is full subtractor. Okay, Amma, fine. So here the difference expression with the help of an XOR gate. And here if you see, Amma, so here you are having x dash, right? So this is x. How to convert that as x dash? With the help of what? With the help of a NOT gate. So therefore I have connected it with the help of a NOT gate, and then I have connected it to AND gates, and finally we have borrow. So is it clear? So what we have to do? We have to first understand the problem, determine the inputs and outputs, name them, draw the truth table, and we have to check whether we can minimize them. Better use Karnaugh map. In all the cases, I want you to use only Karnaugh map. Okay, Amma? Better use Karnaugh map. You minimize it and then you draw the circuit for a minimized expression. Next. So here and the question here is design a 3x8 decoder. So what is a decoder? Actually, subtractor had some meaning. You all know, like from first standard you are studying subtraction, from first standard you are studying addition. So you all know what is an adder and what is a subtractor. But all of a sudden in this unit, we are going to teach you decoder. So again, you need not panic what a decoder is. So what is a decoder? Definitely it's coming in third unit. So a decoder is a combinational logic circuit. And if you see, this combinational logic circuit has got n inputs and 2 power n outputs. So what do you mean by 2 power n outputs? Let us see. So assume, we all know that our computers are having an IC, which is in the motherboard, right? Integrated circuit chip that you will be studying in future as microprocessor. So that microprocessor chip is there. Around that microprocessor chip, if you see, you have got a keyboard input buffer. From the keyboard, we will give input. From the mouse, we can give input. For that, another input buffer. To the printer, we will give the outputs to print. So there is another buffer. So one single processor is there. Around that, you have got a list of another ICs, basically, registers, basically, which are to be connected. And they were connected already. Assume that they were connected already. Now, how to identify that? Suppose if I say 0, if the microprocessor says 0, then keyboard buffer should be selected. If the microprocessor says 1, then who should be selected? Printer buffer should be selected. How to do it? I am repeating. Seema, we are in a computer, we are having the microprocessor. This microprocessor is the central processing unit. This central processing unit has to communicate with the peripheral devices. So the peripheral devices can be a keyboard, a mouse, printer, RAM, ROM. These are all peripheral devices, correct? So how will the microprocessor call? For example, if the microprocessor wants to take the data from the keyboard, microprocessor is not a human being to say, keyboard, come give me the data. And similarly, it cannot say to printer, I am sending you a data, print it. Like that, microprocessor cannot say, right? Because microprocessor is also a chip. So a chip should enable the printer at some point of time. It should enable the mouse at some point of time and the keyboard at some point of time. Again, English, you see, the microprocessor should enable, should select, or should find out, or should say, fine, I'm going to communicate with you. So how is it going to say? For that, first what we have to do, anyhow, we have decided we should use only binary number system, right? Suppose if the microprocessor has to address only two devices, I mean has to select one among the two devices, it just needs one wire to be connected to both the devices. So from microprocessor, a wire will go to printer buffer. From microprocessor, another wire will be going to the keyboard. If that wire carries a 0, then we can assume keyboard is selected. If the wire carries a 1, then we can assume printer buffer is selected. I am repeating. If you are having only two devices to be selected, it is enough to have only one wire. If that one wire is 1, it means one device. If that wire is 0, it means another device, right? Suppose if I am having 4 devices, then with one wire, I cannot have 4 devices to be connected, right? So this wire can have either 0 or 1. So only 2 options are there, but I need 4 to be selected. So instead of one wire, what I have to do is, I have to use 2 wires. So if I use 2 wires, then 4 combinations I will have. It will be 0, 0, 0, 1, 1, 0 or 1, 1, 4 combinations. So indirectly, I am leading you to the definition of a decoder. I am repeating it again, you check. If you have 2 devices, you need 1 wire. If you have 4 devices, we need 2 wires. If you have 8 devices, then you need how many wires? If it is 2, it is 1. For 4, it is 2. So some relationship is there, some mathematical relationship is there. That mathematical relationship is nothing but, suppose if you are having 2 power n outputs, then we should have n inputs. Okay, let us check whether I am right. I said 2 devices, right? So 2 outputs. So 2 devices, 2 power n should be equal to 2. So what should be n value? 1. So 2 power 1 is 2. So I am saying 1 input. I am right. So if you have 2 devices, 1 input. Then I said 4 devices means 2, right? Let us check whether I am right. 4. 2 power what is equal to 4? 2 power 2 is equal to 4. So 2 inputs. Yes, I am right. Suppose if you are having 8 devices, then 2 power something is equal to 8. What is that something? 3. So 3 inputs. That is why your question. 3 cross 8 decoder. Have you understood this? A decoder is a combinational logic circuit that has got n inputs and 2 power n outputs. Actually, reverse we should come. How many devices we want to connect? That should be written in the form of 2 power n, and that n we should substitute as input here. Okay, Amma? Fine. And this is what I have given an application for decoder. It is used for identifying a memory location or a device. I said, right, whether it is a printer buffer or whether it is an input buffer, you can identify it with the help of this. Actually, memory locations can also be identified. That is the real use of a decoder. Anyhow, that you will be studying in computer architecture. So for time being, children, we will understand that a decoder is a combinational logic circuit that has n inputs and 2 power n outputs. So we have already determined the number of inputs, which is 3, because the question is 3 cross 8 decoder. Question is straightforward. So 3 inputs and then 8 outputs. Very good. We have to name them. Again, our wish, A, B, C or X, Y, Z. So I have used X, Y, Z. And the output lines I have named as, I can use alphabets, but still, Amma, like I want to show a relationship between the output variable and the inputs. That is why purposely I have named them as D0, D1, D2, D3, D4, D5, D6 and D7. Okay, you could see D7, but I cannot see D7 from here. Fine. So you see D0. When will this D0 be selected? Okay, now what is D0? It can be a mouse. What is D1? It can be a printer. What is D2? It can be a USB drive. Likewise, D3, D4, D5, D6, D7. So now if you want to select the first device, then you have to give the inputs as what? 0, 0, 0. So if our inputs are 0, 0, 0, then our D naught device is selected. If the input is 0, 0, 1, then D1 is selected. 0, 1, 0, D2. So some pattern is being framed here. So we have to identify what is that pattern. Come, let us try again. See, Amma, 0, 0, 0 means D0. 0, 0, 1 means D1. 0, 1, 0 means D2. So what is it we are missing here? You convert these inputs into decimal number system. 0, 0, 0 in binary is what in decimal number system? 0. So D0 is 1. Let us check whether our pattern is correct. 0, 0, 1 in binary number system, 0, 0, 1. In decimal number system, it is what? 1. See, D1 is selected. Come, let us check randomly. Come here. 1, 1, 0. 1, 1, 0 is what? 4 plus 2 plus 0 is what? 6. So if I am right, D6 should be selected. See, check. D6 is selected. So that is why I have given you a clue for the truth table. See what I have written. Output whose suffix is the decimal equivalent of the binary input will be selected. Shall we see it here? The output, let us take here 3. The output whose suffix 3 is the decimal equivalent for the binary input. So when will you have 3? Only when it is 0, 1, 1. So that is why I wrote the output whose suffix is the decimal equivalent of the binary input will be selected. I think we have learned a lot of story for this decoder. So basically, what is this decoder? I have given you a definition, inputs, outputs, we have drawn the truth table. Next, what is our task? We have to write minimized expressions for the output variables. See here, how many output variables are there, Amma? 7 output variables. So I wrote all the 7. But same logic. When are you having a 1 in D naught? When x is equal to 0 and y equal to 0 and z is equal to 0. So x dash, y dash, z dash. Likewise, randomly come we will do. Here, D5. For D5, where are you having 1? When x is equal to 1 and y is equal to 0 and z is equal to 1. That is x, y dash, z. Check. X, y dash, z. So have you all understood? This is the most important step. What is it for? We have to go to the output variable. One by one we have to go. And in that column, we have to check where all we are having a 1. And we have to write the corresponding inputs. Corresponding inputs which caused us this 1. So if I take D1, I am having 1 only here. So I should go to those inputs. What are those inputs? X equal to 0, y equal to 0, z equal to 1. So it is what? X dash, y dash, z. Only one logic. What is that? Go to that corresponding column, find where all you are having a 1 and write all those inputs which are corresponding to that. So likewise, we have written for D0, D1, D2, D3, so on up to what? D7. So we have to draw a circuit. So, Seema, we know D0 is what? X dash, Y dash, Z dash. So we are having X, Y and Z. So here, yeah, our wish, we can draw X here, Y here, Z here, but accordingly the diagram will change. We should change the diagram, okay? So in this Maurice Mano book, he has taken X here, Y here and Z here. So X dash he wants, so not gate, connected. He wants Y dash, connected. Z dash, connected. I think already you know, but I'm emphasizing it again. So if you have a connection, then you should put a dot over here in order to insist that from here it is connected. Okay, Amma? That's all. So have you all understood this 3x8 decoder? Then there is a diagram, box diagram or block diagram for this 3x8 decoder. So you see X, Y and then Z. And then he has given it as 3x8 decoder. And finally, if you could see 8 output lines, I cannot see here, but I understand you can all see from there, 8 output lines will be there. Okay, Amma, this is the block diagram. But why, ma'am, for subtractor and adder, we didn't draw block diagram, but why, ma'am, for decoder, we are drawing a block diagram? Yes, there is a need for drawing the block diagram for a decoder, but that is not there in your syllabus, but still I'm saying it. See, Amma, with the help of a decoder, we can realize a full adder. We can realize a full subtractor. So if you have to realize a full subtractor, you cannot draw this big diagram for a decoder, and then from here you cannot give connections, right? That's why a box diagram is given. But that may be in later stages you will be learning. Okay? Come, so that's all. 3x8 decoder is over. Before that, I have given you an assignment question. All of you check this. So today, after our class is over, I want you to try this. I have given for 3x8 decoder, but you have to do for what? A 2x4 decoder. You should follow the strict grammar which I have said. What is the problem statement? You have to understand the problem. 1 minute, pa. You all just wait for a minute, ma. Okay. So next slide we will go. Come. So here we have to design a 4x1 multiplexer. Again, I am introducing a new topic to you, which is called a multiplexer. This is the most commonly seen device in any of your future books. Okay, Amma? Fine. So what is a multiplexer? Multiplexer is nothing but the digital electronics answer for choose the correct answer. So 4 options are there. Out of these 4 options, which option you want to select? Only one output. 4 options are here. 1 minute, ma. Sir, solunga sir. Okay, sir. Done. Bye. 1 minute, ra. I am enabling the poll, and you have to give the rating. Okay. So I am giving launch poll. Okay, Amma. But I do not know how to close it, ra. Very good. Oh, my dear. Wait. Okay. Okay, Amma. So now you see, design a, we were in multiplexer, right? Design a 4x1 multiplexer. I said multiplexer is nothing but a circuit for choose the correct answer. In multiple choice questions nowadays, you will have 4 options, right? Among 4 options, you have to choose the correct option. Same thing here, you see, 4 options, I0, I1, I2, I3. Out of these 4, you have to select one option. But which option? Whichever is the correct option, right? So that is English. But for digital logic circuit, how will we say this is the correct option for this particular location? Again, that should be said in terms of what? In terms of gates. Okay. So I repeat, a multiplexer is a combinational logic circuit that has got one output. Yes, only one output. But 2 power n inputs. 4 inputs here in this example. And n select lines. 4 is equal to 2 power 2. So n is 2. Therefore, it will have 2 select lines, namely S0 and S1. So here you see, in an arithmetic unit, a multiplexer is used for selecting any one operation. Same thing. So here I said choose the best answer. In an arithmetic circuit, you will have adder, subtractor, then full adder, full subtractor, parallel adder, BCD adder, etc. Many options. Among those options, we should choose one. Okay, Amma. So I repeat, this is a new topic for you, decoder and multiplexer. So what is a multiplexer? When I say multiplexer, immediately in your mind, you should think our ma'am has said only one output or multiplexer. So a multiplexer is a combinational logic circuit which has got only one output. Okay, what about inputs? I said multiple choice questions, it can have any number of inputs. But any is also wrong, right? There should be some definition, some quantity for any. So for that, you should say 2 power n inputs, and we are having what? N select lines. Have you all understood this? So a multiplexer is a combinational logic circuit that has got 2 power n inputs and 1 output with n select lines. And already we have determined the number of inputs and outputs, 4 inputs, 1 output. But here you have one more in multiplexer, and that is select line. So here we have to define what? Select lines also. So 4 inputs, 1 output and 2 select lines. Okay, Amma? Then we have to name them. So Amma, you have to disconnect your video. Okay, fine. So we have to name them. I am naming them. Here I am adding an intelligence because output side I am having only one output, right? So I am calling it as Y. But now I am having an option for naming the input, right? So here I am using an intelligence, you see. Input first letter what? I. So therefore I named it as I0, I1, I2, I3. Fine. Our inputs, select lines. Select first letter is what? Yes. So I have named it as S0, S1 as the select lines. Okay, Amma? Now we have to draw a truth table. So for this truth table, we should go back to the meaning of a multiplexer. So what is the meaning of a multiplexer? It should select one among the 4 inputs. Okay. So I have named it as I0, I1, I2, I3. So now we have to say to the multiplexer, please select I0. So when will it select I0? We have to say. So what shall we say? Shall we say like this? Multiplexer, your output Y should be equal to I0, provided I give the select lines values as 0, 0. Then multiplexer will ask, why for 0, 0, I should select I0. Why not I will select I1, I2, I3? Like that multiplexer will ask. So to the multiplexer, we have to justify. See multiplexer, if you take the select line values 0, 0, they are binary numbers. If you convert them into decimal value, what value you will get? 0. Therefore, I want you to select what? I0. Similarly, 0, 1, I1. 1, 0 means I2. 1, 1 means I3. Have you all understood this? Now, so I0 is here. This AND gate is for I0, right? So if this AND gate is to be selected, I0 means what, Amma? S1 should be 0, S0 should be 0. Come. S1 should be 0. So inverted. S1 dash. Similarly, S0 dash. Are you all confused? All of a sudden, why ma'am is saying S1 dash, S0 dash? See, it is as simple as that. We have already seen that if X is equal to 0, we should call it as X dash. If Y is equal to 0, we should call it as what? Y dash. Correct? So now, here, S0, instead of X and Y, I have given X0, S0, S1, that's all. So S0 dash, S1 dash. For which AND gate? The AND gate to which I0 is connected. Okay, let us check whether I am right. Let us take I2. To that I2, it should be S1, S0 dash, right? S1, S0 dash. Come, let us check. This is I2. So what did I say? S1. See, Amma, this S1 connected directly. But that is not the end of the story. S0 dash. You see, S0 dash is also connected. So, to that particular values, I0, I1, I2, I3, we have to connect accordingly. S0 dash, S1 dash, S1 dash, S0. Then S1, S0 dash, S1, S0. Then all of them are connected to an OR gate. Why they are all connected to an OR gate? If you see, suppose I want to select I1. If I want to select I1, what I have to do? S1 should be 0, S0 should be 1. You have to listen carefully actually. It is the end of the session, but still I am teaching you multiplexer. It's a very important concept, important everywhere. For all either ECE students or CSE students, it's important. So please listen, Amma, only few minutes, okay? So come. Now we are going to select I1. Okay. So in order to select I1, what did I say? S1 should be 0. S0 should be 1. Come. In this, which AND gate is having this I1? Second AND gate. Super. I am giving S1 as 0. Here S1. S1 is 0. But if you see to this AND gate, who is connected? Not S1, S1 dash. So if S1 is 0, what will be S1 dash? S1 dash will be equal to what? 1. So I1 is here. S1 dash is 1. Then Kanna S0. S0 directly connected, you see, to this AND gate. 1. So a 1 goes here. Now it is AND gate. I1 ANDed with 1, ANDed with 1. So according to an AND gate logic, if anything is ANDed with 1, x dot 1 is equal to what? X. So that x will come here. In all the remaining AND gates, you will have 0 as the answer. So in an OR gate, if any one of the inputs, if all the inputs are zeros, then what will be the output? X plus 0 is what? X. Okay. Have you understood what I'm saying? In an AND gate, x dot 1 is equal to x. In an OR gate, x plus 0 is equal to x. That is why it has been intelligently designed. First English, we understood it, and then we have designed it. So the intelligence here in the entire circuit, the intelligence lies only in what? Connecting the appropriate select lines S0 and S1 to the corresponding AND gates. Again, what intelligence? S0 0, S1 0. Already I said to you, blindly we have to follow. What is it? If S0 is equal to 0, I want you to consider it as S0 dash. If S1 is 0, consider it as S1 dash and connect them accordingly. That's all. So this is a multiplexer. Now, if you closely look at this multiplexer and the previous decoder, both of them are nearly same, but with some difference. Okay, but I think it's time for us to learn. So I have given you a block diagram for the multiplexer also. I want you to compare and contrast a multiplexer with a corresponding decoder. You cannot compare 4x1 multiplexer with a 3x8 decoder and you cannot say, ma'am, input line different, output line. No. I want you to compare 4x1 multiplexer with a 2x4 decoder. Okay, Amma? So you can compare it and you will find something is missing, something are connected together, ma'am, and all that you can do. Okay, fine. So far what we have studied a half subtractor, we have studied a full subtractor, then we have studied decoder, then we have studied a 4x1 multiplexer. Of these 4 which you have studied, multiplexer we will use everywhere. Decoder we will use everywhere. Whenever there is memory, we have to use decoder. Whenever there is arithmetic logic unit, we have to use multiplexer. But children, we will not be using subtractors. So if we do not use subtractor, then your question should be, ma'am, how will we perform subtraction without using subtractor? For that, you have studied an answer in your first unit, right? So instead of performing subtraction as subtraction, we can perform subtraction as what? 2's complement addition. So for the sake of understanding, I want you to understand half subtractors and full subtractors, but never ever our microprocessor or our computers do not use subtractors. They actually use what? They actually use 2's complement adder as a subtractor. But decoder, we use everywhere. Multiplexer, we use everywhere. Then I'm going to teach you another circuit which is very rarely used, but still it has got its own application. And that circuit is nothing but 1x4 demultiplexer. Usually what you will say, ma'am, it is just the opposite of a multiplexer. Yes, it is just the opposite of a multiplexer. You keep like that. because we are not using this demultiplexer anywhere in any of our circuits. So no problem. It's very rarely used. Okay, Amma. So I myself said, right, it is an opposite of a multiplexer. So there one output, here one input. 2 power n input, 2 power n output. But select line should be same, okay, n select lines. So we have determined the inputs, outputs, and also the select lines. Now we have to name them, okay. So here I have given output, but here I have given D, your wish. Okay, Amma. So D or O. O I have given because first letter of output is O, okay. Then same logic, you see, here you are having only one input. That input has got 4 ways to go outside. Which way it has to go, it should decide. Okay, Amma. So that is the purpose of a demultiplexer. We have got 4 options for that demultiplexer. So which way it should go, we have to decide. Okay. And again, that decision will be based on what? Will be based on the select lines. Okay, that's all. So in a demultiplexer, we have got one input. And if that input E should go out of D0, then what should be the values of select lines, you see? Same, similar to that of multiplexer. If D0 has to be selected, D0, 0. 0 means what is its binary value? 0, 0. If D3 has to be selected, then 3 is what, Amma? 1, 1 in binary number system. So how to draw it as a circuit? English is okay, ma'am, but how to convert it as a circuit if you ask? Same logic, 1, 1. If S1 is 1, you should call it as S1. And S0 is 1, you should call it as S0 dot S1. Come, let us check. We were talking about D3, right? If E should come out of D3, then we said S1 should be connected, S0 should be connected. Check whether I am right. See here, S0 is, S1 is connected. Here what is connected, ma? S0 is connected. Similar to that of multiplexer. Okay, ma. Then, even the diagram you see. From this, how can we convert a multiplexer to demultiplexer? You remove it. Remove this OR gate because we need 4 options. We need only one input, right? So connect all these together. So if you connect I0, I1, I2, I3 together, and if you call it as E, enable, then it becomes what? Yeah, demultiplexer. And fine, I wanted to say this, but if you understand, it's okay. This demultiplexer can also be called as an enable input decoder, provided you consider S0 and S1 as 2 inputs, A and B. A decoder is a 2x4 decoder. In order to select a 2x4 decoder, you are having one more line called as enable line. So this demultiplexer can be directly called as a decoder which has got an enable input. This enable input, your teachers will be, okay, like you may find it out as a tri-state logic, tri-state buffer. You will be hearing this word again and again in future. So if you hear tri-state buffer, immediately you should think, okay, our ma'am said already that third state is nothing but enable state. Okay, Amma, so that's all. Fine. So this is a 1x4 demultiplexer. Okay. So, okay. So now we have studied so far subtractors, then decoders, multiplexers, and demultiplexers. Okay, Ma? Fine. So I will find out from your sir whether I am having time to complete this magnitude comparator. Okay. If so, we will go with that. So, okay. So what is a magnitude comparator? We have, okay, today we will learn at least an introduction for this magnitude comparator. So what do we mean by a magnitude comparator? This comparator means it compares. It compares what? The magnitude. What is so big about this magnitude comparator? And why, instead of writing comparator, why did I write magnitude comparator? Like that we should ask. there are three different types of representing numbers. One is sign magnitude representation. The other one is 2's complement representation, 1's complement representation. Suppose if you have sign magnitude representation, then you need not check the sign, right? So we will be checking the magnitude. So when you have to compare only the magnitude, then we can go for a magnitude comparator. Again, you should ask, ma'am, comparator basically, can I use a subtractor? Because when you use a subtractor, you can say whether a number is equal to, whether two numbers are equal to each other, whether a number is, first number is greater than first number is smaller, right? Then what is that? Already we have studied subtractor, then why ma'am again we are studying comparator? So what is the difference between a subtractor and a comparator? We all understand that comparator also will perform comparison based on subtraction only. It will use 2's complement addition only inside. But the comparator will not change the input values. If A is A and B is B, even after performing comparison, you will have the values of A as A and B as B. On the other hand, if you are, Amma, you have to switch off this video, right? Wait. Okay. So, if you have a comparator also performs subtraction, but it will retain the magnitude of the values. Okay, that's it. Whereas subtractor will perform subtraction and it will store the difference as its value. So this is what I have written. A magnitude comparator compares two binary numbers A and B and it provides any one of the three outputs. So when you compare, you can have only